In this first card of a Smart Notebook module for Science 7, students quickly access, save, or print out their retrieval guide. The retrieval guide has students interact with the lesson itself. You can see in card 2 and cards 3 and 4 there are questions. Here's question 1. It's a think question. Question 2 is an investigate question, and then they have to provide a response to the investigation. If we scroll down, we'll see what's available for the teacher on the first card. There's some general information, and at the bottom there's a teacher document which highlights the outcomes which are achieved when this module is taught, and they're highlighted in yellow. This module is designed to have students think about and then draw their own conclusions when they look at the evidence Alfred Wegener had available to them. The first think question: we've all been taught that in the Arctic's far north there are no trees. Why is there fossilized tree stumps found in Canada's Arctic? And you can see Axel Heiberg Island and the sample of the tree stumps there. There's also Canadian content that's attached to it, so they can actually go online and take a look at a newspaper from the north and some of the information that's provided there, so students can interact with Canadian content. In this next investigate card, the question is whether or not the petrified forests in Canada's Arctic are Kluter's history, and students relate it to Alfred Wegener. Now, as they open these up, there's information to tell them how to proceed in the investigation. And there is the puzzle pieces that the students will be using. This is a pretty standard exercise for students to do in Science 7. And there's also a little hint down below for some students that might be having difficulty. The continental pieces will have to fit within the outline. So, how did they do? They have to reveal their best fit, rearranged parts, and then the question is, do you agree with Alfred Wegener that the pieces seem to fit together, or do you think the apparent fit is a chance occurrence? And students will click on there to check how their arrangement worked versus what Alfred Wegener would have had. Everything down here is copyright information, where the images came from, so that teachers and students can be assured that everything is up to par in terms of copyright. The next card looks at biological evidence. That's the think question. Do you think that this evidence supports his claim? And part of biological evidence, they're looking at Lystrosaurus. There's a little video on scientists have made on what Lystrosaurus they think looked like and how it moved in that. And it asks students as well, is there evidence Lystrosaurus is a distant swimmer or could walk great distances? In this next card, students analyze coal beds and mountain ranges, and they're checking to see if they correlate with Alfred Wegener's information. Next card after that has glacial grooves and an image of a glacial groove. And there's a think question that goes with that as well. Do they think is there evidence? In this card, students manipulate and then rank evidence according to most convincing and least convincing evidence. And in this next card, if you were Alfred Wegener, do you think the scientific community would accept or reject your theory? And then it shows it was rejected. In card 11, students are asked to not despair if their good ideas are rejected, because good science and good daily life require both evidence and time before change occurs. What's at the bottom here is A, B, C, and D. There's an Alfred Wegener video. Here is a Pangea. That's an interactive where students can manipulate and reinforce what they've already learned. There's also another animation and a dynamic Earth interactive. The question gets them to summarize everything. Using the information, do you think Wegener's idea can help explain why there are petrified forests in Canada's Arctic? So it kind of puts everything together. relating it again to Canada. The next module is called Magic Motion. There is, of course, teacher information and outcomes, and then there's a student retrieval sheet as well for this one. And this one here, students follow the links, or the teacher can lead this as well, is a video about Alfred Wegener, an interactive on echo sounding using sonar, mapping of the ocean floor, and then a think question. And let's go to the video first of all. The video just provides a little historical information. Why do continents drift? Wegener couldn't explain that, and students are asked to think about the new technology of sonar available after World War II and the information provided. And then they're asked, did that help assist in understanding why the continents moved? In B, there's an interactive. Students use sonar to help map the ocean floor. They get to see how that works. Students get a chance to manipulate this and take a look at how an echo sounding would work. And then they go back and ask, and the question they need to answer is, does this technology help us understand the ocean floor? And this, again, is information Alfred Wegener did not have. Does it help support his theory? So another think question again. There's also two interest links on the bottom. Sonar usage. Did Canadian naval war games assist in the death of a killer whale? So it's a recent article. And of course, for mapping the ocean floor, and then there's other things that can occur. So just general interest links, and then one again on mapping Arctic seafloor and sovereignty. In this card, students examine the volcanic mountain ridges provided by the echolocation and the sonar, and Alfred Wegener didn't have this information, of course. And once again, you can see the copyright links, etc., etc. In this next card, instead of looking at the Mid-Atlantic Ridge, we look at the Juan de Fuca Ridge, the ridge off of the west coast of Canada. Why not do that? And so the kids can see how it's been mapped there. After that, this card, we see seafloor spreading. They put it in a retrieval guide. And the question is, does old seafloor simply accumulate? In science, there's many examples of opposites. What might be the opposite of new seafloor coming up? And of course, then we show them sonar found deep trenches. So they don't know something comes up, something goes down, and they have to speculate at this. Then they take a look at what's occurring at these trenches. So there's three examples of subduction zones they watch. There's a do, quickly sketching with arrows what a deep trench is, or a subduction zone, and then think question, where they have to think about and relate it to Alfred Wegener, and another interest link, Mariana Trench, and that's involving James Cameron again. So Canadian content's really important. Then there's some summary cards. A, continental ocean crust. B, crust broken into plates, tectonic plates. There's a rollover for them to go through to take a look at naming the plates. And then C, at the plate boundaries, seafloor spreading. And we can see right in here, for example, if they click on this, they can see it spreading right off the west coast of Canada, Vancouver Island again, Canadian content. And it continues to summarize all of the information. At the very last card, it's a do activity. It's a plate tectonics tennis ball globe. So it's an activity where kids have to, of course, do the hands-on work, and all the information is provided there for teachers and students. And that helps reinforce their understanding. Self-paced or teacher-led modules. These provide anytime, anywhere access. These are customized lessons so students explore, think, and do. Technology allows us to design lessons which assist students in higher level thinking skills. For example, analyzing Alfred Wegener's available information and thought processes, rather than being told what continental drift is. Students interact with animations, images, videos, and record this information on their retrieval guides, either electronic or print, for reference. These are also flexible. A teacher can use these modules as a regular teacher-led classroom lesson, or students can access it on other electronic devices as a class or at home. These lessons can be adapted and modified easily. If a better interactive is found, it can easily be incorporated. This flexibility applies to integrating recent news items or simply modifying this module as they see fit.